Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have did two numericals which was based on the standard enthalpy of the reaction, that is the standard formation of the reaction, and now we are going to do the third numerical which is based on standard enthalpy of formation of a particular reactant and a product. So let us talk about it, and so let us do the third numerical based on that. So this is a numerical that they have been asking about. So they have mentioned 38.55 kilojoule of heat is been absorbed when 6 gram of O2 reacts with CLF according to the reaction that we have. So the reaction that we have is basically 2 moles of CLF plus oxygen molecule, that is 1 mole of oxygen, that gives us Cl2O, which is in a gaseous form, plus OF2, and we have to calculate what is the standard enthalpy of the reaction. So it is very much easy to calculate, but the thing is we have to calculate the delta H of this overall reaction. So that is what they have given to us, and by using this words that we have, or in the numerical form that we have in this kind of statement, they say that basically 6 gram of oxygen is been involved to give 38.55 kilojoule of heat energy when it has been reacted with CLF. So this clearly indicates that 6 gram of oxygen is been reacted. So suppose if I consider the reaction, so the reaction is basically, again I would write in this format so as to make you understand that how the reaction will have a particular heat of reaction if this quantity of heat or this quantity of reactant is been used. So 2 moles of CLF plus O2, that should give me Cl2O, that is in gaseous state, plus OF2. So in this case what we are observing is we have to calculate what would be the delta H, or standard heat of formation, or enthalpy as we could say, heat of reaction. So this is what we have to calculate, and what data that we have that 6 gram of O2, that is oxygen, liberates, or in that case basically it absorbs 38.55 kilojoule of energy or heat, if we would say. So I would mention in this thing as, suppose that 6 gram can be converted into moles, so therefore I could say that 1 mole of oxygen, that is 1 mole of oxygen, it is nothing but the molecular weight of the oxygen itself. So basically oxygen atoms are basically present 2 times in a molecule of oxygen, so therefore I could write it as basically oxygen plus oxygen. So it will basically 16 plus 16, that will give me something around 32. So basically 32 gram per mole, that would be the molecular weight of the oxygen, or I could say that 32 gram is the one which consists of 1 mole of oxygen molecule. So this is the basically the molecular weight. If I would say, I would write in this format, but actually 1 mole of oxygen contains, therefore I would say 1 mole of oxygen is nothing but it's equivalent to 32 gram of oxygen molecule. So what do we have? We have basically a 6.0 gram of oxygen. So what we are going to do, suppose if we have 6.0 gram of O2, then we have, suppose, considered X moles of O2. So how can we solve this? Means what does 6 gram of oxygen means? So what we are going to do, we are going to do a cross multiplication in this case, and what we are going to get is, therefore X is equals to, we will get 1 multiplied by 6.0, the whole divided by 32. So this is what we get, and we have 0.187 moles. Let me clear it once again. It says that 32, or basically I would say that 32 gram of oxygen is nothing but it's equivalent to 1 mole of oxygen molecule. So therefore what we have therefore 0.87, that is 0.87 mole is equivalent to, this is 6.0 gram of oxygen. And in this case 6.0 gram of oxygen, basically 0.187 mole of oxygen, that is, in that case it absorbs the heat energy of 38.55 kilojoule. So what would be the heat evolved for the 1 mole? It would be very much easy to calculate. Therefore 1 mole of oxygen absorbs Y kilojoule. Again we have to do a cross multiplication in this case. So initially I have taken the one which we have to calculate as X, and now I am taking it as Y. So it would be very much easy to differentiate because I am not considering this as X. So there are the two things that I am mentioning in this case. So therefore I'll again do a cross multiplication. So therefore Y is equals to, it would be 38.55 into 1, the whole divided by 0.187. So let us see what is the answer that we could get. So we have got the answer as 206.149, or we could say 15. So but the energy will be in, yes, kilojoules. The energy will be in kilojoules. So this amount of energy we will get for the overall reaction. So what we had is, we had basically 6 gram of oxygen that was equivalent to basically 0.187 moles that was liberated, or that was being absorbing the heat of 38.55. So 0.187 mole is absorbing 38.55 kilojoule of energy. So what will happen for 1 mole of oxygen? So therefore the 1 mole of oxygen will absorb 206.14. So the overall reaction that what we have got is, in this case, that is CLF, 2 times CLF plus O2 and Cl2O, that we have also a byproduct like OF2, and in this case the delta H naught, that is the heat of the reaction that we have got for 1 mole of oxygen, is nothing but 206.14 kilojoule, and this would be plus. So this is the answer that we have got. Very much easy. But yes, we have to what we have did is, in earlier numerical, that is numerical number 2, what we have converted is, we have converted the number of moles into grams, and now what we have did is, we have converted the gram into number of moles, and in this case we have calculated what will be the standard enthalpy of the reaction, and this were the two difference in numerical number 2 and numerical number 3. So thank you friends for watching this video. I hope you have liked this video, and I hope you are going to try this kind of numerical more and more. So share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.